So to get ourselves kind of settled in the room, take a deep breath with me, will you? Just let the cares of today kind of dissipate. Feel yourself settle into your body. And we'll do that as we listen to some words from Ralph Waldo Emerson, who wrote, "Within us is the soul of the whole, the wise silence, the universal beauty, to which every part and particle is equally related, the eternal one. When it breaks through our intellect, it is genius. When it breathes through our will, it is virtue. And when it flows through our affections, it is love." I think most of you know Anne back there. She's responsible for all this amazing food. And Anne and I are low-budget travelers. And when our kids were small, we wanted to take them on a visit to Carlsbad Caverns as part of a cross-country adventure as a family. Well, the only accommodations that were near the park at Carlsbad were way out of our price range. But we'd heard that it is legal to camp anywhere on land that's owned by the Federal Bureau of Land Management. And our AAA map, remember those AAA maps? Well, it showed this huge expanse of desert right across the highway from the park. So we were like, great, we're all in. And so we drove out a kind of a rugged dirt track and pitched our tent on the dusty hardpan there. And we made and ate supper. But before going to bed, I realized that I needed to use the restroom. Number 2. Oh, no. Yeah. Well, the closest restroom from where we were camped was over the horizon. So what do? Well, we are pretty veteran campers, enough to know that here in Pennsylvania, it's proper to bury one's bodily waste at least 6 inches deep, right? But there in the high desert, proper disposal involves leaving it to dry in the sun. That's just what you do. So I strolled some distance away from our campsite before taking care of business, while enjoying, of course, the crystal clear desert stars, the sky above me. And, you know, at this point, it would be fair if you were thinking that this story involves a painful encounter with a cactus. But no, there were plenty of prickly plants around, but this story's magic begins the following morning. As we packed up in the bright morning sun, we saw something that you cannot see here in Pennsylvania. At different times, 4 large beetles came through our camping area. I see that you can tell where this is going. Each of them rolling a dusty little marble along the ground. And they were on surprisingly straight trajectories. And those tracks exhibited kind of a strange pattern. They seemed to radiate out from a single point some ways off. And I can see and hear that you have guessed what point. But we were mystified. So we followed them kind of in reverse, and we encountered dozens of similar beetles racing out in all directions from the now completely bare spot where I had squatted the night before. How did they find it? Where were they going? It was astounding and kind of unnerving, and obviously made a lasting impression on us and our kids. Well, I now know that dung beetles need those precious brown marbles. They need, I mean, it's essential to their reproduction that they find something like that so that they can feed and nurture their children. And oftentimes in the desert, they only get one shot at it, if they get even one. So I was kind of doing them a favor.
What a generous man.
Well, this happened long before I started thinking in earnest about science and unity. But it was an intimate and kind of a visceral lesson in the ways that I am connected to the world around me, especially the living world. Now, I hate to disappoint, but this is not a talk about dung beetles. It is about the science of oneness. And you might expect science to be a bit of a party pooper when it comes to unity and oneness, a kind of humbug know-it-all who ridicules all that kumbaya stuff in favor of cold, hard reality, right? Well, play along with me here, and let's just see what science has to say about unity and reality. Let's start at the beginning of time. According to the best evidence that science has to work with so far, the universe began as a singularity. What an interesting name, given my topic of oneness today. There's a reason it's called that. The singularity at the beginning of time contained the entire universe, but compacted infinitely dense, so that all of it had no volume, no size at all. Both of these definitions apply there at the beginning of time. The cosmos, our cosmos, was indivisibly singular, and it was infinitely small and infinitely dense. Children's author Carol Martignato calls it the everything seed, the seed that grew into everything. Nobody knows what happened before the beginning of time, but all the evidence we have now says that at the beginning of time, that tiny speck rapidly expanded or inflated, creating space and time as it did. So everything in the universe, from this talk today to interstellar dust in the most distant galaxies, it's all traceable back to that one single thing at the beginning of time. And I want to emphasize that the rest of the story is still about one single thing, evolving through a process of diversifying. At the beginning of time, there was only energy. No atoms, no matter, no mass, no space even. No solids, liquids, or gases, nothing that we would call a thing. It was just pure energy in the form of extremely bright light. Now, matter and energy are a little bit like nouns and verbs. Matter is stuff, things, objects. Energy is movement, action, potential. So, how did the universe make all this stuff if all it had to work with in the beginning was energy? This is tough to wrap our minds around. So I want to use a kind of an analogy. In the sentence, girls are running. Everybody knows that girls can run, right? But they can't become running. Girls are, running happens. As a noun, she can do running, but she can't become running, and the verb running cannot become a girl, right? It's common sense. Stay with me now. Along comes this guy who showed us that the verbs of energy can become the nouns of matter. Running can become girls, and it did. Crazy but true. At extreme energy densities, in other words, when it's hot enough, matter can condense out of extremely bright light. And in the first moments after time began, inside that singularity, particles that would later form atoms of hydrogen and helium condensed out of nothing more substantial than bright light, pure energy. And you know, this isn't somebody's fantasy or daydream. This is what physical evidence tells us happened. And to me, this is a revelation. And I use that word deliberately. Yeah, it's often associated with religion, but I think it's the right word. Carl Sagan famously said, "If you wish to make an apple pie from scratch, you must first invent the universe." And we don't know where that initial singularity came from, or what it would even mean for something to happen before the beginning of time. But we do know that everything in the universe, everything that's an object, as well as all the things that are energies or events, or that are still kind of mysterious, like dark matter, they all have a common origin, a shared genesis in the energy of the Big Bang singularity. You may remember way back in 1969, Joni Mitchell sang, "We are stardust. We are billion-year-old carbon." Well, it's literally true. The early universe only had particles that would later cool enough to form atoms of hydrogen and helium. But that's it. You can't make an apple pie from scratch if all you have to work with in the pantry is hydrogen and helium, right? So where did all this other stuff come from? There is one thing you can make if all you have is atoms of hydrogen and helium. Stars. But stars didn't exist yet. The universe only had this kind of diffuse gas of hydrogen and helium all spread out in space. Over time, a long time, gravity gathered those atoms into the first generation of stars. And that was convenient for us because making heavier atoms from light ones requires really high temperatures, like those found inside the sun, which, as you know, is a star. That's what stars do. They smash atomic nuclei together at such high temperatures that instead of repelling each other like normal, they stick. What? What's he talking about? Well, here's a way to imagine this. Let's say we fired two bouncy balls from cannons so that they collide head on. Wouldn't that be kind of fun? That's the kind of dangerous activity I would get engaged in. Well, at any speed I can imagine, they're just going to bounce off each other, right? They're bouncy balls. And so do the nuclei of atoms, usually. But imagine if we could fire those bouncy balls at such a high speed that the rubber of the balls would actually melt when they collided so that they would end up sticking together. That's a bit like the nuclear fusion process in stars, where temperatures, speeds, are high enough to smash together particles that usually repel each other into ever larger clumps, to turn really simple atoms like hydrogen and helium into heavier elements like lithium, carbon, oxygen, and so on. By the way, fusion also happens in nuclear bombs like most of the ones in the U.S. arsenal today. And one of the goals of nuclear energy research is controlled fusion, so that instead of an explosion, we can make electricity from it. But normal stars can't make anything heavier than iron. And any atoms they do build will just sit there inside the star forever. So none of this planet stuff came from normal stars. But there are some stars, supermassive stars, that sort of live fast and die young. And they go out with a bang called a supernova explosion. And in the moments of that explosion, the temperatures inside are so high that all the other natural elements can be formed. Even really heavy ones like lead and uranium and gold. But then, because it's a supernova explosion, those fusion products get exploded out, dispersed as precious hot dust that gravity then later can slowly collect into new solar systems. But this time, with all that dust available to make planets. And on at least one of those planets, life happened and evolved into the living Earth that we enjoy today. I know, that was a pretty fast trip through nearly 14 billion years of history. But my point here... What's that?
Carl said you would be impressed.
My point is that the seeds of our bodies were present there at the dawn of time. We are descended from stars just like those we see in the night sky. Stars are in our family. We're not only connected to events in the early universe, we are those events still occurring, still unfolding. We're still one thing. With all our diversity, all the different galaxies and stars and planets, and of course the huge diversity of living things on Earth, there is arguably only one universe-sized event that's happening here. A few years after that fateful event with the dung beetles, I was teaching high school physics, and I noticed something about gravity. Now this is high school. So it's Newton's law of universal gravitation. We didn't get into Einstein, which you can use, Newton's law, to calculate the force of gravitational attraction between any two objects. And if algebra is not your forte, you can just close your eyes through this part. You don't need it. Einstein did change how we conceive of gravity, but Newton's equation still works for pretty much everything. You can go to Mars with this thing. And it reveals that gravity is not just something that planets do. there is a force of gravitational attraction between any two objects that have mass, have weight. And you can calculate that force of attraction if you know their masses and the distance between them. And it's weak. Gravity is actually the weakest force in the universe. So you need something the size of a planet to really feel it. Anyhow, I always made up my own homework problems just because I wanted students to personalize the material. And so I'd make up questions like, what is the gravitational attraction between your body and that kid you have a crush on the opposite side of the classroom? And then, what if that person is standing on Pluto right now? And I'd give them the masses and the distances, and they would plug and chug. It was fun. At some point, while I was composing these homework problems, it dawned on me that the answer will never be 0. It can be really, really small. It's usually pretty small. But no matter how small the objects are, or how far apart they are, there is always some small force of attraction between them. This hit me like a 2x4 upside the head. There are invisible threads of gravitational connection, like radiating out from my body, connecting me gravitationally with everything in the universe, from zebras in Zimbabwe to asteroids in Alpha Centauri. Uncountable threads of connection that shift and flex every time I move. The mass in my body helps hold the Milky Way galaxy together. Yours too. So I felt like I had stumbled on something really profound. Another one came when I taught biology and earth science in the same semester. You may remember that photosynthesis allows plants to make themselves, to make their bodies, out of carbon dioxide and water, storing the energy of sunlight in the chemical bonds of sugars. In turn, we make our bodies out of plants, either directly or indirectly. So ultimately, our bodies are made of carbon dioxide and water and sunlight. So I want to take a closer look at carbon dioxide and water. Here's a diagram of the water cycle, and you've probably seen something like this previously. Water evaporates from the ocean, it drifts over the land, and then rains or snows back down, and then runs downhill back to the ocean. But there's something missing here, and it's missing from pretty much every water cycle diagram I've seen. It's us. One of the things some of the water does as it goes around this cycle is be you. Water molecules are so small and so numerous, and they cycle around the earth so constantly that every cup of beverage you swallow contains at least 150 million water molecules that were once inside the body of your faith's founding prophet, whether that's Abraham, Jesus, Mohammed, Buddha, Arjuna, Confucius, Lao Tzu, Spinoza, or Aristotle. Talk about holy water. The longer each of those famous people lived, the more millions of molecules are in your body right now that were also in theirs, being them. And you contain water from every one of them. Every cup of water, including juice, soda, coffee, every cup contains water molecules that were once part of every creature that ever lived on this planet more than a few decades ago. So, we drink this holy water and it comes alive inside us as part of the living system of our bodies. Personally, I think that makes each of us holy too. The carbon cycle is similar, except that as carbon goes around its cycle, it spends time as seashells, coal and petroleum, limestone, concrete, all these carbonate compounds. Also, some time as living processes like our bodies. Some of the carbon atoms posing as you right now were gasoline in my car last winter. And now they're in you. The same is true with the nitrogen cycle, the oxygen cycle, the saline cycle, all these earthly cycles of the atoms and molecules that make up our bodies. You ever wondered what it would be like to be an atom going around one of these cycles? I know, I'm weird, but I have. And that pondering came out as a poem that I like to call An Atom's Life, and I just want to share an excerpt with you. If carbon could choose, would it be a diamond or a daughter? There are entire planets of solid diamond. They do not smell like macaroni, or squeal with laughter swinging between strong hands strolling through gentle breezes. They do not cuddle under downy quilts for communion, cannot dance under hot pregnant skies, their breath and sweat mingling into iron-rich ancestral soils. Yes, if iron could choose, there would be no asteroids. They would fall in swarms, rusty storms of shooting stars, each atom straining with aspiration to become blood-red hemoglobin, light-sensing retinol, muscular myoglobin of living motion, each coveting a chance to live, to bleed, to see the stars, and to reach for them in person. So your body is made of the lucky few zillions of atoms that get to be alive in person as you. So we're part of these interconnected natural cycles that kids study in science class, and we teach them like they're out there somewhere, but they're also right here. We are in those cycles, and they are in us. Every year, about 98% of the atoms in your body get exchanged for new ones. 98%. So a human body is like a standing wave on a river. Matter moves through us and takes our form briefly and then moves on to become something else. Our bodies aren't really things. They're flows. Or maybe more accurately, our bodies are complex patterns in the flow of matter. And that flow is completely interconnected with the Earth as a whole. Because the atmosphere and the hydrosphere and the lithosphere, these are all interconnected systems. You can't draw clear boundaries between them. We are Earth. There are days when I feel like I must have been abandoned here by aliens. But, even if I were, within a year or so, my body would be entirely made up of the water, air, and minerals of Earth. I am Earth. We are Earth. Still happening. And I'm sorry to report that it's not just inanimate matter that cycles through us, because other living things flow through our bodies too, and become us temporarily as they do that. And mostly I'm talking about bacteria here, although fungi, viruses, even arthropods flow through our bodies. On and inside our bodies, bacterial cells outnumber the human cells. There are thousands of species, trillions of bacterial cells, all of them cooperating and competing with each other and with us, with our human cells, all the time. They digest our food, they protect our inner and outer linings, and recently microbiologists have found that the species of bacteria living on and in us influence when we're hungry and thirsty, our food preferences, our weight, even our emotions. So, is it me who loves cheesecake or we? There's a whole ecosystem in here. And the human cells in our bodies each contain dozens of mitochondria, sometimes called the powerhouse of the cell, mostly by high school biology teachers. Mitochondria turn sugars back into energy so that we can do things and keep warm. This is the opposite of photosynthesis. Mitochondria break sugars back down into carbon dioxide and water and energy. And so the solar energy from sunlight comes back out, available to keep us warm or move our muscles, whatever we need energy for. See how this connects with both the water cycle and the carbon cycle? Photosynthesis and respiration are going round and round. Well, we now know that these mitochondria are actually the descendants of ancient bacteria, still operating cooperatively inside our much larger human cells. The mitochondria have their own DNA, separate from the human DNA in our chromosomes. And we use that DNA to discover that you got all your mitochondria from your mother, and she got them from her mother, and so on, because the mitochondria are inherited matrilineally. The mitochondria and sperm don't survive the fertilization, so they all come from the egg. And paleogeneticists have been able to use the well-established mutation rate of mitochondrial DNA to determine that every human being alive today is a direct descendant of one woman who lived in Eastern Africa about 200,000 years ago. And she's referred to as mitochondrial Eve. She's the most recent common female ancestor of all of us. And this is National Geographic's map of how we migrated to occupy every other continent since then. Well, similarly, if you have a Y chromosome, you got it from your father. And like all chromosomes, the Y chromosome accumulates small mutations that get passed on from generation to generation. So we can trace these small differences back through families to find common ancestors. Where do families come together as we go back in time? And we find that they all converge on an unknown man who's called Y chromosomal Adam, the great-great-grandfather of everyone on the planet, at least everyone with a Y chromosome. And no surprise, migration maps from mitochondrial DNA and those from the Y chromosome match up with each other and with anthropological evidence about where humans were when. And I need to emphasize here that mitochondrial Eve and Y chromosomal Adam were not a couple. Don't let those names Adam and Eve fool you into thinking that these are the two mentioned in Genesis. These two almost certainly lived thousands of years and hundreds of miles apart from each other. They 100% certainly were black people. They were African people in Africa. They had parents and siblings and cousins. They were just the most recent ancestors whose mitochondria and Y chromosomes are still around, present in the bodies of everyone that's alive today. Consider the implications of this. This means that every human being alive today, regardless of race, gender, ethnicity, we all have the same many greats grandparents that you do. So think about your neighbors, people you work with, people on the other side of the planet. These are your cousins. There's only one family of people on this planet. Similar genetic analysis and lots of other evidence from many angles of inquiry tells us that every living thing on the planet is a blood relative too, even the ones with nothing like blood in their bodies. We share half our genes with bananas. Like it or not, bananas are my cousins too. And besides, they're delicious. All living things on this planet are related. We are part of a single, unbroken family tree stretching back nearly 4 billion years. Researcher Dr. Daniel Wildcat says, we live among relatives, not resources. We live among relatives, not resources. You may have heard of the butterfly effect, which came out of complexity theory, especially as it applies to weather forecasting. And the idea is that complex systems, like the weather, have so many factors involved in them that they are highly sensitive to small changes that accumulate over time. So, for example, a change as small as a butterfly flapping its wings in Washington can make enough of a difference to cause or prevent a typhoon in Tokyo a month or two later. Well, that means every time you breathe, you change the state of the atmosphere enough to totally rearrange the weather sometime later, because every air molecule bumps into the ones around it, causing them to move and so on. But then the atmosphere is thermodynamically connected to everything. Stock prices, war outcomes, the biosphere, the hydrosphere, mountains, glaciers, everything on the planet. Everything affects everything else sooner or later. And that butterfly effect sensitivity is built into many complex systems, and all those systems are connected. I mentioned gravity earlier. No more equations, I promise. But the orbits of planets, which are governed by gravity, have the same kind of complexity, same kind of sensitivity, because they all experience little gravitational tugs from one another and from the sun, as well as from smaller objects that are the gravitational analogs of butterfly wings. And all of them are in constant motion. And researchers at NASA who model those orbits, trying to prevent collisions and stuff, they told National Geographic that a change as small as moving a pencil across a desk on Earth is enough to shift Jupiter halfway around its orbit 1 billion years from now. That's a small change in a very long time, but still seems pretty significant. Your body is about 10,000 times the mass of a pencil. So those invisible threads of gravitational connection, they're not just some fanciful idea. They actually have gravitas, if you will. There are many more examples of our connection and unity from science. But the bottom line here is that we cannot separate ourselves from the cosmos, or more immediately from the Earth. We are the Earth. The Earth is giving this talk this afternoon, and the Earth is sitting in those earthen chairs listening, right? We and Earth are us, one thing, with many parts. I think our attempts to separate ourselves from the Earth, to exploit and commodify its parts, they're a little bit like me trying to sell my liver or my heart in order to buy a bigger house in a nicer neighborhood. It just doesn't work for very long. Earth's whole and healthy systems are essential to my life. So there's only one story, 14 billion years long. And the characters in the story are completely interconnected on every level of existence. But what about the setting? What about space and time? Well, a century ago, that same smart guy showed us that space and time are actually unitive. They appear different to us, but they're actually a single expression of reality, space-time. And here we are, about a century later, and one of the hot topics in particle physics is non-locality. So we think of space-time as having a framework or a fabric. Even if it bends and curves, there's predictability to it, right? Things can be located. And two different locations are different. There's space between them. And that space is real. Separation is real, we think, right? Well, quantum entanglement calls all of that into question. And evidence is piling up that space-time might be non-local, meaning that maybe location has no meaning. And I'm not going to try to explain quantum entanglement in this talk today. You're welcome. Except to say that two particles that are entangled seem to communicate with one another over long distances instantaneously, faster than the speed of light. Another way to think of it is that entangled particles become a single object that can be in two places at the same time. And this picture is just for fun. Next is a figure from a paper published in 2015 in the journal Physical Review Letters with the title, How Space-Time is Built by Quantum Entanglement. Entanglement giving rise to space-time rather than happening in space-time. That same year, science writer George Musser was published in Scientific American writing, quote, multiple branches of physics now suggest that at a deeper level, there may be no such thing as place and no such thing as distance, end quote. Non-locality suggests that there's only one place here, one location, even after billions of years of cosmic expansion and diversification, as though we are still in a singularity, but somehow diversified. And you know, the name we give this cosmic body of ours offers a clue. One turning, one single event, one song. 750 years ago, long before modern science, the poet Rumi wrote, "You are not a drop in the ocean. You are the entire ocean in a drop." There we go. Coming from science means that these revelations offer to bridge cultural and religious divides, because people all over the world, from all kinds of backgrounds, can look at the scientific evidence and experience the awe and wonder and connection together. But still, what should I do with this knowledge? How does it affect our lives? Well, I think I can start with awareness. When I drink, I can think about how this cup of coffee or juice or whatever contains molecular emissaries from every ocean, from all my ancestors, really from every creature that ever lived. When I look up at the night sky, I can see ancient ancestors and life givers twinkling there and give thanks. When I see a dung beetle cleaning up a mess, I can say, "Hey there, cousin. Congratulations on finding a nice nursery. And thanks for your work." As I walk in the woods, I can see relatives rather than resources. I can greet new people like long-lost cousins I'm meeting for the first time, because they are. Once aware, I can accept that everything I do affects everything else, no exceptions. I can sit with that for a while, letting both the power and the responsibility of it settle in my heart and my mind. I can affirm, I matter. As long as I'm alive, all those interconnected threads run through me, too. Something I'm practicing is to use the word me less and we more. Kind of like that old bumper sticker, think globally and act locally. I try to think of myself as an expression of the universe, a tiny cell in the body of something vast and ancient and dependent on me like I'm dependent on each of my own cells. You know, my blood cells and my bone cells are completely different from one another, performing nearly opposite roles in the ecosystem of my body. But I'd be a mess if my blood cells convinced all of those boneheaded bone cells to become just like them, right? I'd be a puddle on the floor. So unity does not mean uniformity. And it doesn't mean I shouldn't be active in making the world better. It's good that other people are different from me. And, you know, this awareness of universal oneness isn't really new. It's a thread that runs through the fabric of every culture and every religious tradition in one way or another. What's new is empirical, scientific, physical confirmation of it. Confirmation that transcends accidents of birth, like nation, language, and culture. Here's how the Reverend Dr. Martin Luther King Jr. expressed it in his letter from a Birmingham jail. He said, quote, "In a real sense, all life is interrelated. All men, all people are caught in an inescapable network of mutuality, tied in a single garment of destiny. Whatever affects one directly affects all indirectly. This is the interrelated structure of reality." End quote. So what science says about unity and oneness is that your life story and my life story and those of dung beetles and germs and worms and rocks and flocks of geese and the moons and the Pleiades and distant galaxies' life stories are all the same story. Because there's only one story. And there's only one character in the story. We, us, the universe. And I say this not as some kind of religious mystic, but as a hardcore show-me-the-evidence ambassador for mainstream science. And the 7th and the 70th generations of our grandchildren are part of that interconnected web too. What can I do for them today? how will they know that I love them? How can I sing to them across this web of oneness that unites all space and time into a single song? This moment in this talk is that song still being sung. And each of us sings a unique and essential note in the overall chord. We, us, the universe. One song. What else can I do but resolve to treat everyone and everything I encounter as an essential expression of my largest self? Because it is. Thank you for being here.